A Limacon is going to be of the form r equals a plus b cosine theta or r equals a plus b sine theta. A special case occurs when a is less than b. You get something that's known as a looped Limacon. The clue here is that for the first time, with b being greater than a, I can have this term, the b cosine theta, or this term, the b sine theta, become larger in magnitude than the a term. So I can have positive and negative values of r on the same graph. And that's what we have to make sense of. R turning from being positive to being negative. The first case, r equals 3 minus 5 cosine theta. The pattern for cosine is 0. The pattern for cosine is 1, 0, -1, 0. So, in the theta equals 0 direction, I'm at 3 minus 5 times 1. That's going to be 3 minus 5, or -2. So I actually have to go backwards 2 units, facing in the r equals, or in the theta equals 0 direction, but moving back 2. In the pi over 2 direction, I'm at 3 minus 5 times 0. That will be 3. In the pi direction, I'm at 3 minus 5 times -1. That will be 8. So 1, 2, 3, 4, 5, 6, 7, 8. In the theta equals 3 pi over 2 direction, straight down, south, I'm at 3 minus 5 times 0. That would be 3. So 1, 2, 3. Now the question is, how do I get from this point, in which r is negative, to this point where r is positive? The key is that to get from a negative value of r to a positive value of r, I have to let r pass through 0. In other words, to connect these dots, I can't connect them without going through the pole. I have to start by sweeping through from theta equals 0 to theta equals pi over 2. As I'm turning, remember that r is negative, so while I'm looking this way, I'm actually going to be drawing behind until I hit r equals 0, after which r is going to turn into a positive number. R is going to continue to grow more positive until it hits r equals 8. That will be its maximum. Then it's going to start its decline back to r equals 3, back to r equals 0, back to r being a negative number. So when you have r being both positive and negative, you end up with a loop in your Limacon graph. So for the graph r equals 1 plus 2 sine theta, in the theta equals 0 direction, sine is 0, then 1, then 0, then -1. So, initially, in the theta equals 0 direction, I'm at 1 plus 2 times 0. That will be 1. In the theta equals pi over 2 direction, I'm at 1 plus 2 times 1. That will be 3. In the theta equals pi direction, 1 plus 2 times 0. That will be 1. And now for the key. In the 3 pi over 2 direction, I'm at 1 plus 2 times a -1. 1 minus 2 is -1. And so I have to pass through these 4 points. Once again, recall that in this direction, theta is pi, and r is going to be a positive 1, while in this direction, theta is 3 pi over 2, so I'm looking south, but r is going to be negative 1. If r moves from positive to negative, it has to pass through 0. I expect this graph to rise, hit an outer limit of r equals 2. R is going to be decreasing. R is going to turn to 0, and then negative, return to being positive, and the graph will complete. So R is positive all the way through here, but there's going to be that short zone. The zone as we're passing through this angle where R is negative because sine of theta is larger than negative 1/2. Now if you recall, sine of theta is negative 1/2 at minus pi over 6, or we could call that 11 pi over 6, and again at 7 pi over 6. So looking in those two directions, r would be 0. In between, r is going to be negative, and that's going to be this loop around here from minus pi over 6 to 7 pi over 6. R is going to be positive, and that's what gives me the larger loop.